Alright, well, welcome back, everyone. In this video, we're going to spend some time going through some extra practice questions on pointers in C++. Often, students find pointers to be a bit tricky at first. There's a lot of syntax rules and things you need to remember. But once you get the hang of pointers and understand how they work, they're actually quite straightforward to do. And so our goal with this video today is to give everybody some extra practice. Please take the time to go through these questions on your own and make sure you really understand them. The goal of this video is to help you get enough practice so that pointers start making more sense. So please follow along and we'll go through some examples together. So here's our goals for this video. First, we will briefly review pointer syntax rules and some tips for approaching pointer questions. If you'd like a full review of pointers, please check out our previous lecture video. Here we'll just do a very brief review, and then we will complete 4 practice problems, and these are problems I've actually taken from past assignments and past exam questions. So please use these practice problems to help you really get some extra practice in and understand how pointers work. Once again, I highly recommend that you try pausing the video and completing the problems by yourself as we go through them. It's really great practice to attempt these problems on your own and verify that you can get the same result as I do. This is one of the best ways that you can build your understanding of pointers and prepare yourself well for pointer questions on assignments and exams. And once again, for more information on pointers, please do check out our lecture videos as well. So let's briefly review some key reminders about pointers before we jump into our practice questions. So these rules come straight from our lecture, so you can see our lecture videos for more information if you need. First point, remember that the reference operator, or ampersand, can be used to get the memory address where a variable is stored. For example, if I were to write cout ampersand num, that would return the memory address where the variable num is located. Next point. Remember, when you are declaring pointer variables, you need to use an asterisk. So here we have int star ptr1 star ptr2. Here we are declaring 2 pointer variables of int type. Remember, a pointer is a variable that holds a memory address. So here we are declaring 2 variables that can store int type memory addresses. It's very important that you pay attention to what type you declare your pointers to be. Remember, you cannot mix different data types with pointers. So if I declare an int type pointer, that int type pointer can only hold the memory address of an int variable. If I have a double or a char type memory address, we will not be able to store those memory addresses in an int type pointer. Our next rule is rule number 4. The asterisk is a very important tool when using pointers. Remember, if we use asterisk and the name of a pointer, that will allow us to directly access the data that the pointer is pointing at. For example, if I write cout asterisk ptr1, that will return whatever value our pointer ptr1 is pointing at. So for example, if ptr1 was pointing at memory that contained the number 5, we would return the value 5 in that expression. Similarly, I could decide to say, for example, PTR1, if I want to assign PTR1 the value 10, notice that would allow me to go where PTR points and update the value in that memory. Our next rule is about the assignment operator, or our equal sign. Remember that if I use the assignment operator with the pointer variables, that allows us to change where our pointer points. So in this case, we're actually changing the memory address stored inside the pointer itself. So here we're changing where we point, but that's not going to affect the actual data that we're pointing at. Notice, however, in our next rule, Rule 6, that if we use asterisk and equal together, that will allow us to directly change the value that our pointer is pointing to. For example, here we see that we can change the value PTR1 is pointing at using the asterisk and the assignment operator. Rule number 7 is also very important. We can use the new operator to create a new dynamic variable where the pointer points. For example, if I have this pointer PTR1 and I say PTR1 points to a new int, that will make PTR1 point somewhere else. And it will point to some other memory address that is big enough to hold an int in this case. And then we can use this pointer PTR1 in order to access and manipulate that new dynamic variable. Lastly, this rule number 8 is very helpful. Especially when you're first learning pointers, it's very important that you draw pictures when you work with pointers. Not only does this help you keep track of what is happening, but it can also really help you understand what's going on when you're manipulating pointers. You'll see in our example questions that I like to draw pictures of my memory as shown here. There's many different ways you can draw pictures, but for me personally, I like to draw a little box for each of my variables. I write the variable name to the left of the box, the memory address on top of the box, and I put my value inside. Then if I have pointers pointing at that variable, I can draw arrows and make other notes to myself so that I can keep track of what is going on. So as we try our example problems, please consider drawing pictures and following along as we go. This is a really helpful tool to help get better at pointers. So with these tips in mind, let's go ahead and jump into our practice problems. And once again, I highly recommend that you follow along with me as we do these. So let's go ahead and review our practice questions. Once again, these are taken directly from past assignments and past exams. So these should be really good practice. And there's more practice in our lecture videos as well, if you'd like more review. Let's start with practice question 1 shown here. So we have some code where you can see we have pointers and int variables being declared. And our task is to determine what the output of these cout statements will be. In order to keep track of what is happening, it's very important to draw pictures and understand how pointers work. I'm going to go ahead and start this question by first drawing some boxes to keep track of all my variables. you'll notice we actually have quite a few variables here. We're actually declaring 5 variables. So I'm going to go ahead and draw some boxes to help me keep track of them. So what I do is I draw a little box like this. And then here, for example, for A, that's my first variable. It's an int type pointer, so I'll just put a little asterisk so I know it's a pointer. And I currently don't know the value, and I don't know anything about a memory address, so I leave A just like that. I can do the same thing for variable B. B is also a pointer, so I'll just put a little asterisk next to it. And then I have C. So C, also a pointer. And look what's happening here. I've declared pointer C, and it's an int type pointer, and notice it's pointing to a new int. So I'm just going to go ahead and draw another box here, and this box is the dynamic variable that my pointer C is pointing at. I have 2 more variables to go. First is this int variable named lucky number. And notice lucky number is currently initialized to be 7, so I'll just go ahead and put a 7 in there. And finally, I have my last int, which is called mystery number. And mystery number is initialized to hold the value 10. So now we have all of our variables drawn out. And our next step is to read through this code line by line. And as we read through the code, we can update our pictures to keep track of what is happening. Once we've reached the end of the code, we'll be able to look at our picture and figure out what the outputs will be. Let's start with the first line. I'll call it line 6 here. Here we're told C equals ampersand mystery number. Notice here, C is our pointer. So what's happening here is I'm taking my pointer C and I'm making it store the memory address of mystery number. That means instead of pointing at my new int, my pointer C is instead going to point at mystery number. So I'm no longer pointing at that new int. The new int has been abandoned. So now you see my variable C has been updated to hold mystery number, and I've drawn an arrow to help myself keep track of the fact that my pointer C is now pointing at mystery number. On line 7 here, our next line, we have A equals ampersand lucky number. What this is saying is that pointer A is going to be pointing at the memory address of lucky number, or A is holding the memory address of lucky number. So that means this pointer A is now pointing at lucky number. Next we move to line 8. In line 8 we are saying B equals A. B and A are both pointers. So what we're doing here is we're saying we want to assign the value of B to be equal to whatever was inside of A. Remember, if we set one pointer equal to another pointer, that means that we're going to take whatever pointer A holds, which is ampersand lucky number. And essentially what we're doing here is we're making our pointer B point at the same thing that pointer A points at. That's because both pointer A and pointer B now hold the same memory address. Next comes line 9. In line 9, we are saying asterisk B equals asterisk A plus lucky number. Remember what asterisk means. Asterisk B means we go where B points and we update that data to be what A points at plus lucky number. So specifically, we're going where pointer B points, and we're going to update the data stored there to be the data that A points at plus lucky number. Well, we know lucky number is equal to 7. And what is A pointing at? Well, A is also pointing at lucky number, so the value A points at, asterisk A, that's going to be 7. So in this case, we're saying we're going to assign the data that B points at the value 7 plus 7. So now we are updating what B points at, which is lucky number, updating that to be 14. No longer 7. We now hold the value 14 in lucky number. So notice, just by using pointers, I was able to change the values stored in memory elsewhere in my program. All right, we're almost done. In line 10, we are saying A points to a new int. Currently, A is pointing at lucky number. But writing A equals new int, that is going to make my variable, my pointer A, now point at a new int. Notice this is not the same new int we had before. That one was abandoned. So now A is pointing at some other dynamic variable. And here in our next line of code, line 11, we are saying that we want to take the thing that A points at, asterisk A, and we want to set that equal to the data B points at plus the value C points at. Well, if we look in our pictures, we can see that the thing B is pointing at is number 14, because B is pointing at lucky number. Pointer C is pointing at mystery number, which is 10. So here we're going to go where pointer A points, and we're going to make that data equal to 14 plus 10, or 24. All right, we have finally finished drawing our pictures and tracking what's happening. Now we can go ahead and look at our picture and determine the output for the cout statements. First cout statement. We want to output the value of asterisk A. Remember, asterisk A means we go where A points and we return the data stored there. A is pointing at memory containing the number 24. So first, this first line will give us 24. Next, we need to find out what asterisk B is. So we go where B points, and we see the number 14 is stored there. Finally, asterisk C, we go where C points, C is still pointing at the address of mystery number. So C is pointing at the number 10. We return 10. And finally, our last statement, we are outputting the value of mystery number. Well, mystery number is holding the value 10. So in this case, our outputs will be 24, 14, 10, and 10. Notice how drawing the pictures really helped us keep track of what was happening, especially when we were changing the data stored in our variables and when we were changing the locations we were pointing at. And you can see if we were to run this code, we do indeed get 24, 14, 10, and 10 as the output. So definitely give this question a try on your own if you haven't already, and please verify that you're able to get the same result as I did. Let's move on to pointer practice question 2. Notice this question is very similar. Our goal is to fill in the output produced by the cout statements at the end of the question. We do have a little bit more code happening, so we definitely want to make sure that we draw pictures here. Once again, I'm going to start by drawing little boxes to hold all of my variables. So in lines 1 through 4, you can see that we are declaring our variables. So I'm going to go ahead and make a box for my variable a. It's a pointer, so I'll give it an asterisk. Next, I have a pointer b. I have a pointer c. And a pointer, not a pointer. Then I have an int variable called super secret number. And notice we have initialized b, c, and super secret number. B is pointing at a new int. So that's just a dynamic int variable. C is also pointing at a new int. And super secret number is initialized to hold the value 5. Let's now go ahead and read through our next lines of code. And once again, we will update our pictures as we go through each line. In line 5, we say a equals c. A and c are both pointers. C is pointing at a new int, so I'm going to take my pointer a, and it's going to point to the same location where c points, because a and c must be now holding the same memory address. In line 6, we are told that pointer c is now going to point at the memory address. Notice ampersand is memory address. Pointer c is now supposed to point at the memory address of super secret number. So notice now c is no longer going to point at that new int. Our pointer c now holds the address of super secret number. So that means c is now pointing at super secret number. Look what happens in line 7. We're saying asterisk c equals 6. Remember what the asterisk means. We're going to go where c points, and we're going to update that data to be 6? Well, C is pointing at super secret number. So super secret number is going to be updated, and it will now hold the value 6. In line 8, we have asterisk A equals asterisk C plus 3. Well, what's asterisk C? C is now pointing at the number 6. So 6 plus 3 is 9. So in this line 8, we are going where A points, and we're going to update that value to be 6 plus 3, or 9. A is pointing at this new int, so that new int will now hold the value 9. In line 9, we say asterisk B is 2 times super secret number plus where A points. So asterisk A, that's dereferencing A. We see that's the number 9, because that's what our pointer A is pointing at. Since A is pointing at the data containing value 9, super secret number holds the value 6. Here we're saying go where B points, update that data to be 2 times 6 plus 9. 2 times 6 is 12, 12 plus 9 is 21, so our value that B points at is now updated to 21. Let's now do line 10. In line 10, we say asterisk C is equal to asterisk A minus super secret number. So we're going to go where C points. We're going to change that data to be the data stored where A points, which is 9, minus super secret number. Super secret number is 6. So C is going to be updated to 9 minus 6, or 3. But C is pointing at super secret number, so that means super secret number is going to be updated. Now it holds the value 3. Finally, our very last line, line 11, we have asterisk A equals 10. So we're going to go where A points. We're going to change that data to hold the value 10. All right, so we've completed our pictures. Now we're ready to do our cout statements once again. So asterisk A is the value A points at. So A is pointing at memory containing the number 10. Asterisk B, we're going to go where B points and return the value stored there. That's 21. Asterisk C, notice C is now holding the number 3. So we've got 3 there. And lastly, we want to output super secret number times 2. So we have super secret number is 3. 3 times 2, that will give us 6. So there you have it. And you would see if we went through and ran this code in C++, we would actually see that we would indeed get 10, 21, 3, and 6 as our outputs. Alright, so let's now try a slightly more challenging question. In this pointer practice question 3, you see it's a little bit more challenging because we now have a main function and we have a second function named pointer math. But notice that we will start running our program from the main function. The pointer math function will not execute until it is called in the main function. So there's one thing to be careful of when you're approaching pointer questions that have multiple functions. Remember, when our pointer math function runs, these variables x, y, and z, these are going to be local variables inside pointer math. And then, of course, a, b, temp, and random number, these will all be local to main. So when I draw my variable boxes, I actually need to have a partition between my main function and my pointer math function. Inside pointer math, I'm going to have a variable named x, a variable named y, and a variable named z, which is a pointer. But these variables, x, y, z, they're only going to exist inside pointer math. However, when I call pointer math, some values from main are going to be plugged in. We'll return to pointer math a little bit later. For now, let's just draw those variable boxes so that they're ready to go. Back in my main function, let's now draw the variable boxes for the pointers and variables we've been given. So in lines 1 through 4, we declare 4 variables. We have a pointer named a, and that pointer a is pointing to a new int. Pointer b is also pointing to a new dynamic int variable. We also have a pointer named temp, and currently temp is pointing at the null pointer. And finally, we have random number, which is an int variable. And random number is just an int. It's initialized to hold the value 5. So there's our values. Everyone has now been initialized. Remember, in this case, the null pointer, that's just memory address 0. But most likely, temp is going to be pointing at something else very soon. Let's go ahead and read through our code line by line, and we'll keep track of what happens as we go. Let's start with line 5. In line 5, we are assigning asterisk a the value random number. So we're going to go where a points. That's our new int. And we're going to set the value of that memory to hold the number 5. So now a is pointing at memory that stores the same value as random number. Next, in line 6, we're saying asterisk b equals 11. That means we're going to go where b points. And set that data equal to 11. So b is pointing at an empty, uninitialized new int. So we update that to hold number 11. Next, we run line 7. In line 7, we're going to take our temp pointer, and look what happens. Instead of pointing at null pointer, we now want to point at the same thing a is pointing at. So now temp is no longer pointing at null, temp is pointing at the same thing that our pointer a is pointing at, because the two pointers are equal. Notice what happens in line 8. In line 8, we declared a new variable named answer. So we have a new int variable, And in the same line of code, we are assigning answer the value returned by the pointer math function. So we're going to call the pointer math function, and notice what's happening here. For the x variable in pointer math, we are plugging in asterisk a. Well, what's asterisk a? Asterisk a is 5. So we're going to go into pointer math and we're putting in 5 as the value for x, because that's what we're plugging in the function call. For our second argument, we are plugging in random number, which is also 5, but notice there's an ampersand. This ampersand means pass by reference. Remember what pass by reference means. When we do pass by reference, that means any changes made to our variable y, those will also change random number back in my main function. So what I like to do in this situation is I like to put a special note here. And notice what I'm doing is I'm putting a note that our input for y is random number. So we're going to go ahead and plug in random number's value, but any changes made to y in pointer math, those changes will also any changes made to y in pointer math, those changes will also change random number back in main. So it's very helpful to draw extra arrows here and make a note to yourself so that you remember. Finally, the last argument we're plugging in is we're plugging in the value stored in temp for our pointer z. Temp is pointing at a new int holding the value 5, so z is also going to point where temp points, because remember, we're basically plugging in the same memory address. So z is going to point where temp points. So there we go. We have substituted all our values in for our pointer math function call. Since pointer math was called, it's now time to execute the code inside pointer math in order to trigger the function. And notice whatever value we return is going to be stored in that new variable answer. First, we assign x the value 5. Well, x is already equal to 5, so we don't have to change anything there. But look what happens to y. Y equals asterisk z plus x. Well, asterisk z, that's the value z points at. Z is pointing at 5, so we plug that in. And then x holds the value 5, so y is going to be equal to 5 plus 5, or 10. But since y is passed by reference, we also need to update random number to hold the value 10. Remember, due to pass by reference rules, any reference variable changed in pointer math also will have the changes made in main, because we're changing this random number variable directly in pointer math. Last item in pointer math, we're writing asterisk z plus plus. That's the same as writing asterisk z equals asterisk z plus 1. Well, z is pointing at 5, so here we're going to take that number 5. We're going to say, now you're going to be equal to 6. So we're going to go where z points, set that value equal to the value we're pointing at plus 1. So we get 6. Finally, our pointer math function must return a value. So here we are returning x times y. Well, x is 5, y is 10. So x times y is going to be 50. So we're going to return 50 into answer. Because 50 is the result of our pointer math function. And now we are ready to output the results to the screen. We can now look at our picture and figure out what each cout statement should show. First is answer. We see that answer holds the value 50. So the answer for this first cout statement is 50. Next is asterisk A. Well, we look where pointer A points. Pointer A points at 6. So the second cout statement will output 6. Next, we go to our value B. Here, we look where B points. B is pointing at the number 11. And lastly, we go where temp points, and we output the value temp is pointing at. That will give us 6. And there you have it. So we have now successfully gone through and updated our results. All right, let's now finish up with our practice question 4. In this question, we are once again given some memory addresses to assume for our various variables. Notice we also have a function called foo_a and a main function. Remember that the foo_a function will not run until it is called by main. So we'll want to start our program inside our main function. But like before, we're going to need to keep track of two sets of variables. We have the variables declared in main, which are local to main, and we have a separate set of variables that exist only in the foo function. Let's go ahead and first draw out these different variables just so we can keep track of everyone. So I'm going to go ahead and make a partition here. Remember, I have my function foo_a, which will have its own set of variables. Inside foo_a, I have a variable named a, which is just an int. So I'll give it name a, address, I'm told, oops, it's not 1000, but 2000. So I have variable a stored at address 2000. I have variable b inside foo_a, and that variable is stored at 2004. Then I have a variable c, which is a pointer, because we see it has int asterisk, and that variable is stored at address 2008. So those are the variables inside foo_a. Let's now go inside our main function, and let's go ahead and update our variables in main. In main, I have another variable named a. Remember, this variable a is local to main. Since it's declared in main, it only exists in main. It has the address 1000. Similarly, my variable b in main has the address 1004. Variable c in main, I'm told, has the address 1008. And notice variable b is a pointer, so I'm just giving an asterisk there so I remember. Then we have our variable d, which I'm told has the address 1012. And finally, my variable e in main, which has the address 1016. Let's go ahead and read our main function line by line, starting with line 1. And as we run our main function, let's update our memory inside our boxes that we've drawn. First, we have int a equals 5. Remember, we're inside our main function, so we're going to set our a variable in main to store the value 5. Next, our pointer b in main function, this is line 2. Notice we're making our pointer b point at a new int. We have a 9 in parentheses here. That means that we are initializing that int to hold the value 9. We're also told that any new dynamic variable will return the address 5000. So that means that b is going to be pointing at some new int from memory address 5000, and this new int stores the number 9. Let's continue with line 3. In line 3, we're initializing our variable c to hold -2. In line 4, we have declared our variable d, but notice we have not actually given d any value, so we'll just leave it empty for now. Oops, one thing I forgot. Notice my pointer b is pointing at this new int, so pointer b will hold the address of the int. Lastly, we declare a pointer e, and we know that that pointer e is now holding the memory address of variable a. So we know that variable a is stored at address 1000. So pointer e, let's go ahead and give it an asterisk since it's a pointer. We can draw an arrow to remind ourselves that pointer e is pointing at that int variable a. Pointer e holds a's memory address. We are now on line 6 of our program. Notice line 6 is a call to the foo_a function, and whatever thing foo_a returns will be stored in our uninitialized variable d. So in this case, look what we are plugging in for our foo function. We happen to be plugging in our variables a, b, and c from main into the variables a, b, and c inside foo. So let's go ahead and plug those in. My variable a in main holds the number 5, so I'm going to go into my foo function and I'm going to plug in that exact value 5 into my variable a inside foo. Next I plug in, notice my asterisk b. Here that means I'm going to plug in the value b is pointing at. So I'm going to be plugging in 9 for my second argument in foo, but look what's happening here. There's an ampersand. That means we're doing pass by reference again. So what that means is this b variable is passed by reference. So in this case, since I'm plugging in the thing b is pointing at, I need to be careful here because any changes made to that variable b, those changes will be, any changes made here in foo will be reflected back inside my main function. So I have drawn this pass by reference arrow to remind myself that any changes that I'm making to this value stored at pointer B's location, those changes will be reflected. Finally, for my last argument, I'm plugging in the memory address of C. So notice here, the memory address of C is 1008. So here inside asterisk C, I plug in 1008. Oops, and I forgot to write in. Notice I plugged in asterisk B for my int value, so I'm going to plug in the number 9. So let's go ahead and run this foo_a function. So first, we have b++. Well, we're going to go ahead and say b equals b plus 1. So in this case, well, b is currently pointing to the value 9. Well, we're going to go ahead and change that. B equals b plus 1. That's going to change the value to be 10. And notice, because of pass by reference, my value is updated in both locations, both in foo_a and in main. Next, I have a plus equals asterisk c. That means a is equal to a plus asterisk c. Well, notice here, for my pointer C, I plugged in memory address 1008. That means pointer C is pointing at the memory address of C back in main. So if I do asterisk C, I'm going to return -2. I also know that my value of a in foo_a is 5. So here, 5 plus -2, that's going to give me +3. So my value a inside foo is going to be updated to be 3. Notice this value a in foo is a separate local variable a. It is separate from the value a in main. This is foo_a's variable a, so only the a variable in foo_a will be updated. Next, we have a cout statement, so let's go ahead and determine those outputs. We have b, which will be 10, asterisk c, which is what c is pointing at. That will still be -2. A is now 3, and the value stored in C, notice that is just the memory address that C points at, so that will be 1008, because C currently holds the memory address 1008. Last line here, we have C equals &A. Notice what that's going to do. We are going to be changing the address stored inside C. This is now changed to hold the address 2000. That means pointer C in foo_a is now pointing at my int variable a inside foo_a. Finally, I do this return statement. I'm returning a minus b. So in this case, I look at my variable a holds the number 3, b holds the number 10, so 3 minus 10 will give me -7. That means when I jump down back to main, I'm returning -7 into my variable d, because that value returned by foo_a is going to be stored inside d. Now we have finally finished running our code. Let's determine the last of our outputs. So first we have our couts for a and b. Notice we're inside main now, so we have to return the values in main. So we have 5 for a. The value stored in b is our memory address 5000, because that is the address held by that pointer. Asterisk b returns the thing b is pointing at, which in this case will be 10. Next, we output C. The value stored in C is -2. Finally, we output D, which is -7, and E, which currently holds the address 1000. Asterisk E is the thing E points at, which is number 5. In our second line of cout, we have &A. That's the memory address of A in main, which is 1000. Memory address of B is 1004. Memory address of C is 1008. Memory address of D is 1012. And memory address of E is 1016. And all of those were given in our original information. So there you have it. We have successfully determined the outputs for all of our cout statements. I hope you found these practice problems helpful, and I definitely encourage that you go back through these examples on your own and make sure you understand them. One of the best ways to get good at pointers is to draw pictures and follow this exact procedure to really understand what each line of code is doing in your questions. Feel free to reach out if you have any other questions on this, and definitely check out our earlier lectures on pointers if you'd like additional information and more practice. Thanks everyone, and we'll see you in the next video.